Okay, good morning class. So we continue. So just now the last video we have discussed about 5.2.3, the parametric equation of a parabola. So the parametric equation of a parabola is x equals at squared and y equals 2at. Alright, this is for if the vertex is the origin. So if vertex is not the origin, then this is a parametric equation. Still remember? Okay, so now we will continue. Alright, to 5.2.3.1. So how we are going to find the chords, tangents, and normals to the parabola by using the parametric equation. Means involve the parameter. Okay, so let's see. Suppose that point P with parametric coordinates AP square to AP, alright, and another point Q also lies on the parabola with coordinates AQ square to AQ. Alright, okay, so 2 points on the parabola y squared equals 4ax. So this is an example where the vertex is at the origin. So this is the diagram. Point, let's say P here and Q here. Alright, so the gradient for chord PQ. Alright, the gradient for chord PQ will be y minus y, okay, over x minus x. Alright, so we factorize the 2a, so left p minus q. This one we factorize out the a, so left p square minus q square, right? And we know that p square minus q square can be factorized as p minus q, p plus q. Alright, then the p minus q can be simplified. Okay, a and a simplified. Therefore, you see that the gradient of the chord PQ will be 2 over p plus q. Okay, so the equation of the chord PQ will be, so we choose p as a point. So y minus y to AP, m, x minus x, AP square. Okay, so after you simplify, you multiply the whole thing by p plus q. After we simplify, so you will get this equation. So this is the equation of chord PQ, or any chord on the parabola, which is p plus q y equals 2x plus 2apq. Later, how to simplify, later we will have example, we will discuss in more detail. Alright, then when the point Q moves towards P, let's say as what we have done before, right? Okay, as what we have done before, let's say Q is moving closer and closer to Q. Okay, where we have I have shown you this one on ellipse, or when we discuss about ellipse. Okay, so you see that when Q moves towards P, so means let's say Q move here, so you see the chord PQ getting shorter and shorter. Let's say Q move here already, then you see the chord PQ getting shorter and shorter, remember? Then then the chord PQ getting shorter and shorter. So until when Q equals P, means that the point Q coincide with the point P, just like ellipse. Okay, Q move closer and closer to P until one moment they intercept each other. Alright, so the chord PQ now become the tangent. Alright, when closer and closer, though it become the tangent at point P. Alright, so just now we already said the gradient for chord PQ is 2 over P plus Q. Since now Q is overlapped with P, means Q and P are the same. So become P plus P, so 2P. So 2 and 2P simplified, so the gradient of the tangent at point P will be 1 over P. So this is how we get the gradient of the tangent. Memorize this step, because it will sometimes the question will ask you to show how you obtain the gradient of the tangent. So you have to start from here. You have to start from the chord, get the gradient of the chord. Alright, then mention that Q moves towards P closer and closer until one moment Q coincide with P, so Q and P same, then substitute. Alright, this is how you explain how you get the gradient of the tangent at a parabola. Alright, then hence the equation of a tangent will be same. We take P as the point, and this is the gradient, so y minus y equals m x minus x. Alright, so again, after you simplify, means you multiply the whole thing by P. So this is the equation of the tangent at point P. Or you can shift your p to the right hand side and write it in the gradient form, which is y equals 1 over px plus ap. All right. So this is gradient of tangent. Then how about the gradient of the normal? The gradient of the normal means the line pass through P also, but perpendicular to tangent. So this is called normal. Alright? So just now the equation of tangent is 1 over P. Since normal is perpendicular to tangent, therefore the gradient of the normal will be negative P. This one positive, this one negative. This one 1 over P, this one P. Alright, so this is the gradient of the normal. Hence, the equation of the normal at P will be this one, same. Y minus y equals m. Now your gradient is negative P, m x minus x. Also, again, after you simplify the whole thing, so this is the equation of the normal at P. So this paragraph show you how to find the gradient of chord PQ, how to find the equation of chord PQ. Then from the concept of chord, how you can get the gradient for the tangent, all right, and the equation of the tangent. Then from the tangent, we can find the gradient of the normal and get the equation of the normal. Make sure you are very clear about these three things. Okay, because you see that parabola actually came out twice in STPM. Okay, so I will discuss quite many examples so that you can get the idea how to solve question like this. All right, okay, so the first one, we will look at one example in your textbook. All right, so please open your textbook, page 243. Okay, my version is 243. All right, which is example 5.26. All right, example 5.26. Okay, here. This is one of the example that related to parabola with parametric equation. All right, so the question is like this. You are given that point P with coordinates AP square 2AP and Q, AQ square 2AQ. These 2 points lies on the parabola y square equals 4ax. This is the standard one. So we know that this is a parabola with vertex at the origin. Find the equation of chord PQ. All right, find also the focus of the midpoint of chord PQ. See, given that P and Q are those points for which PQ equals 2a. After that, sketch the graph of the locus of point, the midpoint. All right, so I sketch a diagram so that you can see clearer. So this is a parabola. All right, let's say at the beginning, P is here. At the beginning, the black color, P is here and Q is here. All right, so this is chord PQ. So the question wants you to find the equation of chord PQ. All right, and also the focus of the midpoint of chord PQ. See? So means that it involves the midpoint. So let's say if P is here and Q is here, so midpoint M is here. So let's say P and Q move, right? P and Q can move. Let's say at one moment P move here, Q move here. So this is chord PQ. So the gradient become here already. The midpoint here already, right? So again, let's say P now move here and Q move here. All right, so this is chord PQ. So the midpoint M will be here. See that? So when P and Q moves, the midpoint of chord PQ also moves, right? So now they want you to find the focus of the midpoint of chord PQ. So means this point M also moving, and it is actually moving in a shape, in the locus. And actually, you know that this locus, this is another parabola. So they want you to find the focus of this parabola. The parabola of locus of M. Not this original anymore. Alright? And the further information they give you so that you can find the focus of the midpoint of the chord PQ. They tell you that actually P and Q are those points for which PQ equals to A. This is further information given to you. Then after that, sketch the graph of the locus of point M. Alright? Okay, so you see how they do it. So because involve midpoint, right? So I have to know, we find the gradient of chord PQ first. So this is what we have explained just now. Y minus y over x minus x. So after simplify, this is the gradient of PQ. Then find the equation of PQ. Y minus y equals mx minus x, like what we have discussed just now. So you see the whole equation multiplied by p plus q. So this one multiply p plus q. This one multiply p plus q. So when this side multiply p plus q, simplify, left 2 only. So 2x, 2aq square. Okay? So this one move here. So this one 2aqp, 2apq. So 2, and then 2aq square, see? Minus 2aq square. And here also 2aq square. So this one actually simplified. So left 2x. So 2apq shift here become plus 2apq. So you get the equation of the chord. Alright. Then after that, to find the coordinate of midpoint, because this is asking by the question, right? Find the equation of chord PQ. Also, we have to calculate that. So next is to find the coordinate of midpoint of PQ. Now we want to coordinate of PQ. So we have coordinate for P and Q already, right? So use the midpoint formula. X plus x over 2, y plus y over 2. Alright? Therefore, your x is, because a and a, they can factorize out. So a over 2. So left p square plus q square. Alright, so from here, because means find the locus of the new thing means we don't want the parameter anymore. We just want x and y and some constant. For me, in this question, the constant is 2a. A is a constant, so it can leave it in your locus. So what we want to eliminate is a parameter, means p and q. Okay. So I just a question rearrange this so that this one shift to the right hand side. So it's 2x over a. Then compare the y coordinate. So 2a factorize out. So 2 can be simplified. So left a, p plus q. Alright, therefore p plus q is y over a. Okay, now we want to eliminate p plus q, right? Okay, so you see p plus q, because I have p square plus q square here. So we square p plus q. Also is p square plus q square minus 2pq. Okay, and what is p plus q? P plus q is y over a, right? Sub in y over a square. And p square plus q square is 2x over a. See? And what is 2pq? So just now given in the question, right? pq is 2a. This is definitely their reason why they give you extra information. Alright? So sub in. Okay, so you see that now left one equation with only x, y, and a. A is a constant, can remain. We just don't want the parameter. Parameter p and q, right? So after you rearrange, square this one, and you rearrange in a nice way, so you see that the whole thing multiplied by a square. So left y square, this one multiply a square, 2ax. This is my plus 4a cube, because multiplied with a square. I think they make mistake here. It should be minus. Okay. Alright. So this is so you can mention. So this is the standard form of a parabola. Therefore, point M, the locus for point M is also another parabola. Okay. And locus of the midpoint of PQ. So the sketch is this thing. So remember how to find the focus. So when you learn parabola, okay, in parametric form, y squared equals 4ax. So a is actually the focus. If it is at the origin, if it is at the origin, then a is the focus. Alright, A0 the focus is. Alright. So if it is not the focus, then we have to plus minus a k loss, you remember? We will see this one. Okay, so now let's see how they can get this thing. How they can get this focus. Okay, alright, so I see that there is a mistake in the answer, because this one I suppose is minus. So therefore this one also wrong. Alright, it's okay. So this is the new solution. Alright, so y squared equals 2a. So I factorize out 2a. Alright, so it's 2ax minus 2a squared. Therefore, correct lah. Therefore, you will get your 4a cubed. Okay, so we know that the standard form is y squared equals 4ax, right? Y squared equals 4ax. So I have to write in that way. So y squared equals 4ax. Of course, the a that I mentioned here is this one. It's the if it is at the vertex is at the origin like this. Okay, so this a is not this a lah. Okay, this is the a that I mean. This is the a. So when 2a I write in 4 something, right? So this is the a that I want. Because this one related to focus, remember? So if the vertex is at origin, so y squared equals 4ax, therefore the focus will be a 0. Remember? This one show us the focus. Alright, but this equation, this parabola, the what I want to say, sorry. This parabola, the vertex is not at the center. The vertex is not at the center. This is the vertex. Alright, so the vertex is actually x is 2a squared, y is 0. Alright, so if this is the vertex, so here, you see this is the parabola. This is the vertex. Okay, so where is the focus? Because the question actually wants us to find the focus. But this question the answer show us the vertex. I think either here mistake or here mistake. Doesn't matter, we will just show both. So because just now it says a wrong answer here, right? Therefore here also wrong. So this is wrong. Okay, so this is a vertex. And remember, if the vertex is at origin, then the focus is a unit to this side. Means is for this one is half a unit to this side. But now the vertex move to the right 2a unit, right? Okay, therefore the focus also move 2a units. So the focus, this is the focus, this is the vertex. Will be 2a squared plus half a. Okay, means that originally if the vertex is at the origin, so the focus is here, which is half a. From here we know. Alright, now the vertex shift 2a squared. So the focus half a also shift 2a squared. So it's 2a squared plus half a. Okay, so this is the vertex, this is the focus, and sketch the graph. So means that I know that my diagram is not that good. It don't show the what. So means that this point M actually also move like in such a way. Alright, so means when PQ move, so this point M also move, and this is the locus for point M. Alright, why I get something like this, or why I get something like this? Because this is not accurate. When I sketch this diagram, I don't consider this part. Where PQ equals 2a. This is the extra information given to us. So if PQ moves such a way, such that PQ is always equals to 2a, then yes, you will when we mark the point M, you will see it's something like this. Okay, so this is a good example how to find locus. So you see that many questions, the following question will similarly always related to find the midpoint, find the locus of the midpoint, something like that. All right. Okay, so next, okay, after this question, so we will go to checkpoint 5.6, page 245. So we are going to discuss 2 questions here. So in your textbook, there's only 2 questions related to this chord, tangent, and normals to the parabola. Alright, there are actually more on hyperbola and also rectangular hyperbola. Also in this textbook only have 2 questions, alright, related to parabola, which is questions 6 and 7. Okay, page 245. So I'm going to discuss both the questions. Alright, so I'll show you the question first. If someone have different question, then you know. Okay, so this is question 7. You are given that the line passing through the point P on the curve y squared equals 4x, and also point Q, which is 2, 0. Alright, so intersect the curve once again at point R. Find the coordinates of R in terms of P. Then show that when P varies, the midpoint of PR lies on the curve. See? They want you to find another locus, which is the midpoint of PR. Okay, so the locus of midpoint of PR is this one. This one, the answer given. You just need to show this thing. All right. So I think I move the question a bit here so that you can see the question when I discuss. All right. Okay. You can see. All right. Move a bit this side. Okay. Yeah. Yeah, can see the whole question. This one also can see. A bit smaller a bit. Okay. Yeah, better. All right. So let's see. So always sketch a diagram lah. So the question say you have a parabola. All right. Y squared equals 4x. So it's clear that the vertex is at origin. So the parabola. All right. Point P given. Let's say this is P. P is here. All right. With coordinate P square 2P. Okay. So there is a line passing through P on the curve and another point Q 20. So 20 is here. Okay. So there's a line pass through P. P is on parabola and pass through another point on the x-axis. All right. So this is PQ. So you see that the curve cut the parabola again at R. So R is here. Okay. So they want you to find the coordinate of point R in terms of P lah. Then after that, show that the midpoint of PR lies on another, is the locus, the locus of midpoint PR is another parabola. All right? Okay, so this is the diagram. Therefore, this is the coordinate for point P. So this is the equation for the original parabola. Y squared equals 4x. So when we compare to the standard form, 4ax, so it's clear that a is 1. Right? Then the gradient for PQ, we calculate gradient for PQ. So y minus y over x minus x. Okay? Therefore, the equation for PQ or PR will be y minus y. So I'm taking Q lah. Don't take P lah. Then it become complicated, right? So we take, because Q also lies on the line. So use this point will be easier. Okay? So y minus 0. This is m. X minus 2. All right. Okay. So we left it in this way. Okay. So now we want to calculate point R, right? So we know that this is the parameter coordinate. So at P is P squared 2P. Therefore, at R, very simple, is R squared 2R. At P, parameter equals P. So at R, parameter equals R. Okay, so the coordinate for R will be R squared 2R. So if we can get R, means we know the coordinate for R. All right. Then since point R also lies on this line, right? This line. All right. Therefore, we can sub these two coordinates into this line. Okay. So sub y equals 2R, m. So x equals R squared. Sub in here. So we want to find R in terms of P. Okay, so now the gradient multiply in, so become like this. All right, then we multiply the whole thing by P squared minus 2. So P squared minus 2 R. So this one multiply P squared minus 2, simplified, left 2PR squared. This one left 4P. All right, then we rearrange it. Remember, we want to find R. So we rearrange and become a quadratic equation in terms of R. Okay, so 2PR, left it here. Okay, so this one shift it to this side. So minus 2P squared minus 2R. Okay, minus 4P. So you see, you get a quadratic equation in terms of R. All right, so to find R, it's clear lah. This one cannot be simplified. Cannot be. If you are good enough to factorize, then it's fine. Okay. If you are good enough to factorize it, then no problem. Okay, no problem. We can factorize it, but it's quite difficult lah. So we use the quadratic formula. All right. Negative b, because negative here also negative, so become positive lah. So negative b plus minus. So b squared minus 4ac. Okay, so this one too I multiply in first. This one, 2 square is 4. So elaborate this. So p square and square, p power 4. 2 multiply this one, minus 4p squared and plus 4. This one, when you multiply, is 32p squared. Alright, so 4 multiply in. 4p power 4 minus 16p squared plus 16. Alright, this is minus 16p squared, right? So minus 16p squared plus 32p squared. So left positive 16p squared. Okay? So this one, this thing is actually can be factorized. 2p squared plus 4 and square. You see? 2p square is 4p power 4. 4 square, 16. 2 times 4, 8 times 2, 16. So 16p square. See that? Alright, so square root and square simplified. So you get 2p squared minus 4 plus minus 2p squared plus 4 over 4p. Okay? Therefore, r equals, I do the plus 1 first, or r equals the minus 1. Alright? So you see, 2p squared plus 2p, minus 4 plus 4 no more. 2p squared plus 2p squared, 4p squared. 4p squared over 4p, p lah. Okay, so we reject this one. Why? R equals p. Okay, the x coordinate is p, means it is actually for point P. Don't forget, P and R both lies on the same line. Okay, so when you solve, definitely you will get two different values of R. So R equals P is actually referred to point P. So we reject it. So this is the R for point R. Alright, so you have 2p squared minus 2p squared no more. Minus 4 minus 8. So negative 8 over 4p is negative 2 over p. Yes, this is your R. Okay? Then after that, the coordinate for, you can see here. Okay? So the coordinate for R is R squared 2R ma. So R is negative 2 over p squared to negative 2 over p. So this is the coordinate for point R in terms of p. Okay? So we have answered the first part. Find the coordinate of point R in terms of p. Alright, now we want to find the midpoint of PR. Okay? So put here easier to see. Okay. So we already get, here. Okay, we already calculate point R. So this is R and this is P, right? So the midpoint of PR, so use the formula for midpoint, x plus x over 2, y plus y over 2. So it's like this. So after simplified, you see this one simplified, combine become one fraction. So it's P squared. Okay, so P power 4. So times 2. Okay, this one also combine them, become like this. Alright, so this is 2p squared minus 4. So p moved to the denominator already. So this is the midpoint. Alright, so remember I said before, to find the locus of a point, we find the coordinate, the parameter coordinate of the point. Then we eliminate the parameter. So now the parametric coordinate of point M is this one. So P is the parameter. So now we want to remove the parameter. So we will get one equation in terms of x and y only. Or another, if got other constant. This question, no other constant. So this is the x coordinate. This is the y coordinate. Alright, so how we can eliminate them? So actually, very simple. You see, I see p power 4 plus 4. I see p squared minus 2. So I know that I must square this thing, so that I will get p power 4 plus 4. Alright? So you see, alright, for x, I take out the 2 first, like this. Alright, easier for me to, so the 2, I shift it to this side, so 2x. Later, easier for me to factorize, to suck in. Okay, so you see, this is coordinate y, so I square both sides. Square both sides, then only I can get this thing. See that? So this is how we determine what are the next step that we want to do. Okay, so p square, a square is power 4, negative 2 square is 4. So 2 times 2, negative 2 times this one is negative 4p square. Alright, so this one also square. Okay, then I split this one into two fractions. One part is this one, another part is this one. P power 4 plus 4 over p square minus 4p square over p square. Split into two. All right, and now sub this one in. See, this p power 4 plus 4 over p square, same. So this is actually equals to 2x. This one p square and p square simple minus 4. All right, so you see, you get a parabola equation. So this is the locus for point M, which is the midpoint of PR. So when P and R change position, okay, M also move. M also move and change position, and M move follow this locus. Clear? So we have discussed actually quite many questions already, right? Where you're asking to find the locus of a point. So you see the general step normally most of the time the general step is you try to find the parameter coordinate of the moving point. Then you try to eliminate the parameter. Okay, so this is question 6. All right. So I show you the whole solution for question 6 so that you can, if you want, you can snap down. You can snap the picture. Question 6 start from here. Diagram. Find the gradient. The first part is find the equation of line PR. So find the gradient, sub into the formula and get the equation. Then find coordinate R. All right, use the parameter, sub into this equation to find your R. Okay, so get the equation for point R, then can calculate the midpoint in parameter P. All right, then from the two parametric equations, eliminate the parameter and get the equation of the another parabola. All right, you can snap down this solution. Okay. All right, so next we will go to question 7. Question 7 is simpler, which is, you see that the solution is actually shorter. Okay, so question 7 say, you are given point R with coordinate 2r squared 2ar and point S, as squared 2as, lies on the parabola y squared equals 4ax. So again, this is a parabola with vertex origin. Find the equation of chord Rs. So like just now, if this chord passes through the focus of the parabola, show that Rs equals -1. All right, so if the chord passes through the focus, so it means no matter where R and S move, or R and S moving around, right? But no matter where they move, Rs must pass through focus. This is the condition for them. Okay, then from here, show that Rs equals -1. Okay, so not difficult. So you are given the parametric coordinates for R and S. All right, and this is the parabola that these 2 points lies on. All right, so we find the gradient for chord Rs. So y minus y over s minus s, x minus x. So you see all with a, so can simplify the a. All right, so 2 and 2 factorize, so left r minus s. Okay, whereas this one left r squared minus x squared. So we know that r squared minus s squared can be factorized at r minus s, r plus s. All right, so r minus s can be simplified. So this is the gradient for chord Rs. Okay, then we choose R as a point to find the equation of the chord Rs. So y minus y, m, x minus x. We choose point R. You can choose point S also. Actually, you will get the same answer. All right. So we simplify it by multiply the whole equation by R plus X. So R plus SY. So 2AR also multiply R plus S. So when this right hand side multiply R plus S, simplified, so left 2X 2AR squared. All right. So expand this one. Minus 2AR squared minus 2ARS. So 2AR squared minus 2AR squared, no more, simplified. Okay, so you have 2x. This is y, shift it to this side. And this one, shift it to this side. So this is the equation of the chord. All right, so sorry, this is the locus for point, hold on. No, sorry. Yeah, this is the equation for chord RS. All right, equation for chord RS. So you see the question says find the equation of chord RS. Done? Okay, then after that, show this part. To show this part, the extra information given to you is the chord passes through the focus. So where is the focus? So we know that this is the parabola, where the vertex is at origin. So the focus is A, 0. So the focus is A, 0. All right, so since this chord passes through this focus, so we can sub x equals A, y equals 0 into the equation of the chord. All right, so x equals A, y equals 0. So this one no more because multiplied with 0. Okay, so 2a plus 2a RS. So I shift 2a to this side, minus 2a. So 2 and 2 simplified. A and A simplified. See? So RS equals negative 1. That's it. Okay? So this is question 7. All right? In your textbook. Okay. So next, we'll go back to the notes. All right? We go back to the notes. Okay, we can make it bigger. Okay. All right. Okay. So just now we have see the example in your textbook, and we have do checkpoint 5.6 questions 6 and 7. All right. So I'm going to discuss another 2 more questions. All right. Question 3 here. Okay, so you can see. Okay, let me put it here a bit so that it won't fly. All right, so question 3 here. Obtain the equation of chord joining the point P and Q. So you see, do it again. All right. On the parabola y square equals 4ax. So from here, very clear, it is the parabola at the where the vertex is at the origin. Okay. Then find the points of intersection of the tangent at P and Q. This is a longer part. Okay, and then if PQ pass through point AA, find the locus of the point of intersection of the 2 tangents. Okay, so what does this mean? So again, always sketch the diagram. So this is the parabola vertex at the origin, because it's y square. Yeah, given is y square equals 4ax. Okay, there are 2 points lies on PQ. So P and Q. Okay, so the question first want you to find the equation of chord PQ lah. So as usual, we discussed this one twice already. Okay, this is the 3rd time, so I go quite fast. So you are given point P and Q, find the gradient of PQ. Okay, and the equation. All right, then how to simplify? Multiply the whole thing by P plus Q. Okay, step by step, you simplify it. Then I write it in general form. General form means X followed by Y followed by C. Okay, so this one 3rd time already, so I go quite fast. All right, then next the question say, find the point of intersection of the tangent at P and Q. So let's say this is P, so this is the tangent at P. So this is Q, this is the tangent at Q. So you see that these 2 tangents intersect at point T. That's why when you have a diagram, you can just label. When I label later, I can just straight away say at what. Right? If you without the diagram, you just don't simply say at T. So where is T? The examiner don't know where is T. So but with the diagram, I labeled very clear, so I know that T is the intersection point of these 2 tangents. Because the question never tell you what is the point, so I name it so that easier for us, right? So they want you to find the intersection point first. Okay, so very simple. We have to find the equation because this is intersection point. So I need the equation of these 2 tangents. Okay, so we find the equation of tangent at P first. All right, so you have learned this one, right? In the notes at the beginning of this video, you have learned the gradient for the tangent is 1 over P. Because P, the parameter is P, so 1 over P. So use point P. Use point P. Y minus Y equals mx minus x. All right, so multiply. So you get this thing. Y here. or this one expand, or 1 over p multiply ap square, so become minus ap lah. So minus 2ap, shift it here. Okay, minus 1ap plus 2ap, so positive 1ap. So this is the equation at P. All right, so at P, I show, this is the equation of the tangent at P. So at P, I show it clearly how I get it. So at Q, no need to show lah. If the gradient of the tangent at P is like this, then the gradient of the tangent at Q will be like this. Oh, this is 1 over P, then this is 1 over Q. This is AP, this is AQ. You don't have to show it. Okay, because when you show it also, you get the same thing. Okay, so the first one, of course, you have to show clearly. So let's say I name this one as equation 1 and 2. Therefore, at point T, or at the intersection point, so these two must be the same, right? This y and this y must be the same. So this one and this one same. Okay, so I group the x together. So this 1 over qx shift here and factorize out. So AP, I shift it here. Okay, and I factorize out. Factorize the A. So this one I combine, become one fraction. All right, PQ. So this one times Q, this one times P. All right, so where is X? X is, sorry. So this one shift to the left hand side actually become PQ, Q minus P, right? When this one shift here. So that is simplified. So left APQ. Okay, so the X coordinate for point T I already get APQ. So to find y, very simple. I sub it into 1. You can sub into 1. You can sub into 1 or 2. So I choose to sub into 1. Sub in here. So y equals 1 over px. So x is apq plus ap. All right. So p and p simplified. So it's aq plus ap. So I factorize out a. So y is a p plus q. Right? So this is the coordinate for point T. X is APQ, Y is A, P plus Q. Okay? So we already calculate the coordinate of T. Then next, PQ passes through AA. So means that no matter where P and Q move, chord PQ must be always pass through point AA. Let's say point AA is here. All right? So means that when P move here, let's say next P move here already. So the Q must be here. Okay, so that it will pass through the same point. This is the condition given. All right, let's say I show you a few positions so that you have a clear picture. Let's say now P move here. So let's say now P move here. All right, so where is Q? So P must be passed through here. And yes, where is my black? It's okay. So Q is here already. Q must be here. See? So when P move, Q also move. But now they give you the condition. No matter where P and Q move, the chord PQ must pass through point AA. So let's say point AA here. Can I? If P here, then Q must be here. So that pass through this point. If P here, Q must be here. So that it pass through this point. If P here, Q must be here. So that it pass through this point. All right? So when P and Q change position, the tangent also change, right? Let's say if this one, P here, the tangent here already, Q, the tangent here. So T, the intersection point T will move, lor. Okay? So let's say P move here already now. So the tangent will be here. So I hope you won't confuse you. Then Q must be here. So the tangent here. The tangent for Q now here. So point T change here already. See that? So when P and Q move, but with condition, chord PQ always pass through this point. Then the intersection point T also move, you see? T also move. So now they want you to find the locus of this point T. All right? So remember, just like I said, to find the locus of a point, first you get the parametric coordinates for the point. Then you eliminate the parameter. All right? So now the parameter is P and Q, right? A is a constant. A is a constant from the equation. So A can be remain. Okay, we just want to eliminate parameter. Parameter now is P and Q, right? Okay, therefore, I shift it here so that you can see it. All right. Okay. So, what is it? No need. This one something special lah. Okay, this one something special. Oh, we don't have to eliminate the parameter. We don't have to eliminate the parameter from here because it's a little bit complicated. We don't have information to eliminate PQ and P plus Q. We don't have relation. We don't have, in this question, we don't have relation between PQ and P plus Q. Yeah. It can also actually. When I square this one. No, it become complicated. Okay. So for this question is something special. We don't have to use the parametric coordinate for point T to eliminate the parameter because they tell us that point AA always lies on PQ. Point AA always lies on chord PQ. So we can sub AA into the equation for chord PQ, which is this one. This one. Just now we calculate already, right? The equation of chord PQ, we calculate already. Okay, so we can sub point AA into this equation. Therefore, 2x, right? So 2x become 2a, x is a ma. Then minus P plus Q, y. Y is also a. Then plus 2a PQ. Okay, yeah, we still use the parameter equation. We still use the parametric coordinate. Yes, we use. Okay, so when sub AA into the chord PQ, I get something like this. Okay, now at point T, remember just now, point T, x is APQ, right? Y is AP plus Q, right? Then we sub these two parametric coordinates or parametric equation into this chord equation. All right. So 2a still 2a minus AP plus Q is y. Okay. APQ is x. So 2x. Yes. Okay. So I shift the y to this side. So this is the equation of the locus of point T. Y equals 2x plus 2a. So it's a straight line. Locus for midpoint T is a straight line. So actually I show two examples here, you also can see. It's a straight line. Just now P here, also somewhere here. So T will move along this straight line. So the locus of another point not necessarily will be another parabola or curve. It can be a straight line also. Okay, so when PQ move, but no matter how they move, they must pass through point AA. Alright, so the intersection of their tangent, point T, also move. And this T move along a straight line. Okay, this one simpler. So this is question 3. Alright, in the notes. Okay, you can snap down. Okay, next. We will go to question 4. Alright. Okay, we will go to question 4 here. Question 4. Alright, so actually this question 4 is a little bit similar to the question checkpoint 5.6. Question 6 that I discussed just now. Where that I discussed just now, this one, question 6. See, it's quite similar. So this is the question 6 that we discussed just now. You see the diagram? So this is the diagram for question 6 that we discussed just now, and this is the diagram for question 4 now. All right, you see they give you the a point. This one they give you Q is 20. This one they don't give you a number, they give you A. This is actually the focus. This is not focus. Okay, so it's quite similar. So this question just now, question 6, because they give us parametric, right? The parameter P and then this Q. So I calculate the parametric coordinate for r. So I use a longer weight method. Remember just now question 6? So now this one we can use a simpler method compared to this one. So we will see. Alright. Okay, so it's like this. Okay, so you see PQ is a chord of the parabola x equals at squared and y equals 2at. Alright, so it's actually, they tell you that when you see x equals at squared and y equals 2at, it's actually the parametric coordinates. So when you have these parametric coordinates, definitely the equation of the parabola is y squared equals 4ax. Okay, where it is vertex at the origin. They just give you in different way only. Okay, and which passes through the focus A0. They also give you the focus. So the diagram is like this. The parametric equation. Okay, so from these two parametric equation, I know that the equation of the parabola is this one. So this is a parabola where the vertex at the origin. Okay, and the focus is A. So now they tell you that find the point, find the chord PQ and which passes through the focus. PQ is a chord which passes through A0. Okay, show that the locus of midpoint of PQ is another parabola and hence find the equation. It's quite similarly to this question just now. Just that the information given to us slightly different. Okay, so means that no matter where PQ move, it must pass through this one. Let's say again P move here. So where is Q? Q must be here, or it must pass through the focus. So Q must be here, cannot be go other way. All right. So if P move here, then where is Q? So Q must be here. But the PQ must always pass through here. Pass through the focus. Okay. So we want to find the midpoint of chord PQ. So like we just now we are using the parametric equation, right? PQ, write it in this way, then find PQ. Now we change to another method, or we use another method to calculate, which is simpler actually. So let's say this is the let's say the gradient for PQ is m lah. Or we use small letter m to represent the PQ lah, because they tell us PQ must pass through focus A0. Alright, so we can find the equation of PQ by using the formula y minus y equals mx minus x. Alright, so pass through this point, y is 0, x is a. And just now we say that the gradient for PQ is m. Alright, so this is the equation of chord PQ, y equals m, x minus a. Okay, so you see that actually this question they never ask us to find, because this question they never ask us to find the equation of chord PQ. They never ask. Okay, therefore we don't go through the long step like question 6. Okay, we just get this thing. What we want is actually the midpoint. Alright, so let's say there is a point with coordinates at squared and 2at. This is the general one, right, from here. Lies on the parabola and also PQ. Okay, so means that this is one of the moving point of PQ lah. Okay, so this point must lies on parabola and also PQ. So it show you that this is the coordinate. This is a parametric coordinates for P and Q. It must be P or Q lah, right? Only P or Q lies on the parabola and at the same time lies on chord PQ, right? So now what we are going to do is we want to find T lah. Okay, we want to find T so that we can find the coordinate for midpoint. Alright, so how are we going to do it? So we sub these two xy into the equation of chord PQ. So y is 2at lah, m, x is at squared minus a. This a, not 0. Okay, then next, continue here. Okay, so I simplify it. Or you see that you have a here, you have a here, you have a here. So can be simplified. All right, so left 2t. This one mt square. This one 1, after simplify is 1. So minus m. All right, so you see that I can rearrange this one as a quadratic equation in terms of t. T is a parameter, remember, it can be changed. So you get mt square. This one shift to this side, minus 2t minus m. So I get a quadratic equation in terms of t. Remember just now, we say we want to find t, right? Because t, we will find two different values of t. One is p, one is q. Okay, so T1 and T2 are, let T1 and T2 be the parameter for point PQ for point PQ. All right, and we know that T1 and T2 are the roots for this equation, right? T1 and T2 also the roots for this equation. Okay, so the next step will be we don't have to find Q, we don't have to find T, but for this question, we want to use, okay, so for this question, we want to use SOR and POR. So from here, you can see that actually there are many ways for us to solve, So this is one of the method. Okay, so look at this quadratic equation. So remember the sum of roots. Just how we say, right? T1 and T2. T1 and T2 are the parameter and also the roots for this quadratic equation. All right. So the sum of root will be T1 plus T2 and equals to negative B over A. Remember? Negative. So B over A. So it's 2 over M. Okay. Then product of roots is T1 times T2. So it's negative C over A. C over A. So M and M simplified. So the POR is negative 1. Okay, so just now we say T1 and T2 are the parameter for point P. So from here we can say that point P is AT1 square 2AT1. Q is AT2 square 2AT2. Okay, so we find the midpoint. Okay, from here we find the midpoint. So midpoint is x plus x over 2, y plus y over 2. All right, so let's look at the x coordinate. So this is the x coordinate. I factorize out the a or a over 2. Then you have T1 square plus T2 square. All right, so when I have T1 square plus T2 square, I know that I can factorize at T1 plus T2 square. So you have T1 square plus T2 square. So I have one extra 2 T1, T2. So I have to minus out or something like completing the square. Okay, so from here you see that what is T1 plus T2? This is why I want the sum of roots. T1 plus T2 is 2 over M. So sub in 2 over M square. What is T1, T2? T1, T2 is negative 1. Sub in. All right, so your x coordinate will be this one 2 square is 4. 4 times 2 is 2 so 2a m square. All right, so this one multiply in, so 2 and 2 simplified, so plus a only. Okay, this is the x coordinate. Okay, let's look at the y coordinate. So 2a I factorize out, so T1 plus T2 over 2. So 2 and 2 simplified. So what is T1 plus T2? Again, is 2 over m. All right, so remember we want to eliminate the parameter. Now a is a constant because a is the equation, is in the equation. Okay, a is a constant, but m is our something like variable. Because m is the gradient for PQ so when PQ change, m also change, right? Yeah, so we want to eliminate whatever changing. Okay, so we want to, so in this case, you see x in terms of am, y also in terms of am. So the value that which varies is m. So we eliminate m. All right, so I rearrange this one. M I shift here, y I shift down. So m equals 2a over y. Okay, so sub this m inside here. Sub this m inside here. So I continue here. So x, this is x, x equals 2a over m. M is 2a over y. This is over m. So I move up, so reverse lah. Become y over 2a square plus a. Okay, so simplify. So y square lah. And then, yeah. Okay, this is 4a square. So simplified with 2a, left 2a lah. So y square plus a. So the whole equation times 2a. So I have 2ax. This one simplified no more. Plus 2a square. Alright, therefore, y, when I rearrange it, sorry, don't shit. Okay, so when I rearrange it, you get y square equals 2ax. This one shift to this side, minus 2a square. Okay, let's just see nicer. This is question 4. That's okay. Alright, okay. So you write the conclusion. So I rewrite it. Because I see 2a and 2a squared, I factorize 2a. So y squared equals 2a x minus a. Alright, so this is the standard form of the equation of a parabola. Right? Because the question wants us to find it, show that the locus of the midpoint of PQ, which is M lah, okay, is another parabola. So this is how you show it's another parabola. Okay, and find the equation. This is the equation. Or you answer the question in one time. Or you answer both. Okay. So I repeat a bit. So this is question 4. Or sketch the diagram. So you see, this is another method I use lah. Because they give us this one, so I can find the chord PQ in terms of M. Alright. Then again, I also calculate PQ. I also calculate PQ, but not in terms of parameter P and parameter Q. I use T1, T2. Okay? Then from here, I use SOR, POR, so that I can submit the value to get X in terms of AM and Y in terms of AM. Then we eliminate the variable M. So you get one equation in XY only. A is okay, as I say again, A is a constant here, so can remain. Alright, so you get the parabola, another equation, the equation of another parabola in terms of A. Okay? So, question 4 and question 6 in checkpoint 5.6, they are similar questions. So that just now that one is I use longer method PQ. Now this one, another way we can do it. Okay? Alright. Next. Another 2 question is STPM question. These 2 questions I want you to do as quiz. Alright? I will explain how to do it. So you after this video, immediately you complete it and upload to the Google Drive. Okay? Before you can go for rest. Before you can go to another subject. Okay? Okay. See, I move it a bit to this side. Okay, question 5. Alright, so you see, a parabola is represented by the parametric equation 2t squared y equals 4t. So write down the parametric equation. P and Q are 2 points on the parabola with non-zero parameter P and Q respectively. Okay, then point S is the focus. Right? So I sketch the diagram. Parametric equation. So these are the parametric equation given to you. Alright? So I always compare to the standard one. The standard parametric coordinates for parabola is x equals at squared, y equals 2at. Alright? So from here you are clear. Is it 2? If I write in the way 2at, 2 times 2. So this one A is 2. This one also 2. Alright, because I want to find what is A. Okay, and it's very clear that the origin is, the vertex is at origin. Because X and Y doesn't minus or plus any number, right? Okay, so when I rewrite it, actually the parametric equation, the equation of this parabola is y squared equals 4ax, right? So your A is 2 ma. So for this parabola, the equation is y squared equals 8x. See, it's not asking lah, but I just show you. The most important thing is I want to know what is my a. Okay, so this is a parabola vertex. Okay, just now the question said S is the focus, right? Actually, from here I know what is the focus already lah. Okay, later they ask you to find. Okay, then point P and point P and R is here. Okay, so since you are given the parametric coordinates, so from here you know that at point P the coordinate is 2p squared. This is 2t squared ma. So at P is 2p squared, 4p. So at Q is 2q squared, and 4q. Okay. So these are the information you should get. Then now you can answer. A, find the gradient of chord PQ. No problem, right? You have the coordinate already. We have discussed 3-4 times already how to find the gradient of chord PQ in terms of PQ. All right, then deduce the gradient of tangent at P. It's at the beginning of the video, remember how to deduce? You say, look, Q move forward. When Q move closer and closer to P, then P, the small p equals to the small q. Then from the gradient of chord PQ, you get the gradient for point P. You see? So at the beginning, we have explained this concept and asked you to memorize it. You see? It can ask in STPM like this. All right. Then B, determine the coordinates of A where the tangent to the parabola at P cut the x-axis. All right. So let's say P is here. So this is the tangent. So this tangent cut the x-axis at point A. So they want you to find this A. Okay. So to find A, no problem, right? You find the equation of the tangent. So you know the gradient already. You know the gradient of the tangent at point P. You have the coordinate. So you find the equation of tangent. It's also stated in the beginning of the video. Okay? Here. Remember this part? Or this part. Alright? Stated. Of course, you don't copy the formula from here. You still need to show, because in part A, you already show all this thing. Right? Then you follow this step. Okay? Sub in the point. Okay? So when you get the equation of the tangent at P, so can you calculate A? Because A is on x-axis, so that y will be equals to 0, right? Sub y equals 0, you get your x. So you calculate, you get your point A. That's why you see very simple, 2 marks only. If 2 marks, then means you direct can use a formula. Because 2 marks only. So you can direct use a formula, then sub y equals 0 and find your x. Alright? And find your x. So, but they want coordinate, so please write in full. Okay, please write in full. Coordinate A. What is the coordinate for point A? Alright, part C, state the coordinate of S. This one no problem, right? State, just write the answer only. And show that AS equals PS. Alright, so you have the coordinate for P, you have the coordinate for S, you have the coordinate for A. So use the distance formula. Use the distance formula, calculate AX, calculate AS, calculate PS. ASPS. Calculate using the distance formula and show that they are the same. Okay, that's why this one more marks. And the part D, determine the coordinate of R in terms of P where the normal equation to the parabola at P meets the parabola again. It involves normal. So this is the tangent. So the blue one is the normal. The blue one is a line normal. So this normal go through point P and cut the parabola again. So this is point R. Alright? So they want you to find the coordinates for this point R. So no problem, right? You have the gradient for tangent, so no problem to get the gradient for PR. Okay? And you have coordinate P. So you have gradient, you have coordinate, you know how to find the equation of okay, you find the equation of PR. Okay, you have the gradient, you have the point, so you find the equation of PR. Alright, then R is the intersection point, right? R is the intersection point of PR with the curve. Yes. So you solve simultaneous equation, the curve of the parabola with the equation of PR. Alright, so definitely you get 2 answers. One is for P, another one will be Q. That's why this one longer, 6 marks. It's a long question. It's a long question, which is 15 marks. All right, so again, if 15 marks means when you want to complete this question 1.5 minutes, right? 1.5 minutes means you will get the most 23 minutes. You must complete this question. 15 plus 7.5, yeah. The most 23 minutes you have to complete this question. Half an hour lah. Okay. Then next question will be STPM 2019. So you are given that a parabola has the parametric equation. Also given you the parametric equation. 2016 also given you parametric equation. So 2019 also give you parametric equation. So I write in this way. All right. T can be any real number. Show that the coordinates of the focus is 20. Same. They want you to find focus. All right. Then a line passing through the focus cut the parabola at point P and Q. So if the value of T at the value of parameter at point P is 2, find the value of T at Q, 5 marks. So this question, 8 marks only. It's not difficult. So I show you. All right. So you see, you are given this parametric. So I see plus something here. So I know that this one, the center is not origin. I have to shift this one to this side. Become like this. Okay. So compare the standard form. If the vertex is not at origin, x minus h equals at squared, y minus k equals 2at. So the h and k will be the vertex of this parabola. You will compare. So can you find the vertex? Yeah. Okay. Then find the focus. Find the vertex. Then find your A. Okay. Determine your A. Then you can find the focus already. Can. Then you can find the focus already. So this is a parabola. All right, you sketch the parabola. So the question say that I'll show the focus lah. So this one 3 marks. Answer given to you already. So you must show how you get the focus 20. Okay. Then a line passes through the focus. There's a line pass through focus and cut the parabola at PQ. Okay. Then they tell you at point P, T is equals to. So this is T lah. So sub T equals to in here and here. So you get point P. All right. So next step is they want you to find Q ma. All right. So to find Q, I need the equation for PQ. Can? So can you find the gradient for PQ? You have point P, you have F already, right? Use these 2 points to find the gradient. Then you use point P, so you can form the equation for PQ. Alright, so after you get the equation for PQ, so you know that you can sub in this parametric coordinate into PQ to find T ma. Alright, to PQ. So because PQ pass through the parabola. Alright, so find T for point Q lah. So of course you will get 2 T's because you see quadratic. So 1 T is equals to 2. So you reject. You use Analytic. Okay? So 8 marks means it's about 12 minutes. So just now about 23 minutes, 12 minutes. So you need to use 35 minutes to complete this quiz. Alright, so just now we start at actually just now we start at 8:15, right? So this video is about 1 hour 15 minutes. So 8:15 9:15, 9:30, 10:30. Okay, means you have finished. Okay, you have finished the lesson for T. So so you have half an hour break to continue to another subject, right? Okay, it's okay. So I want you to use the afternoon 1 hour. Okay, 2 o'clock to 3 o'clock. It's a homework time for Max T also, right? So so please use the time 2 o'clock to 3 o'clock to complete these 2 quiz. Okay, so means that by 3 o'clock, everyone should upload the answer for these 2 into the Google Drive. Okay, so you do your homework. You find another time to do your homework. So your homework will be Blangi textbook. Because as I say, in your this recent textbook, you only have 2 questions related to this part. But you see, it came up twice. In STPM. So you maybe stand by. So you need to do more questions. So please, Yu Xian, remember, please take the old Belangi textbook, page 201. All right, please snap the question from question 6 to question 12. Snap the question 6 to question 12 and forward into the our MaxT group. Okay, so that everyone can try these 7 questions when you have time. Okay, you should try more questions lah. Anything you don't know, then please ask lah. I will try to show you the solution. Okay, all right. Thank you, class.